Okay, for 5C, the thing we need to remember about compounding interest, about finding time with compounding interest, is that time is in our exponent. So remember that we are going to use either y equals a times b to the x or y equals a times e to the rt. And either way, our time is in the exponent because remember, x is the number of times that interest is calculated. So it's going to be like number of years times, months or quarters or whatever, how many ever times it's calculated per year to get number of times it's calculated altogether. So for this one, when we're finding time, you want to write x with a label. So it will be like an x equals however many months or quarters or years if it's annual, but weeks, etc. If you are using continuously, that is always years. Okay, so doing that and then remembering that because my exponent is the part that I don't know, I am going to get my b to the x alone or the e to the rt alone, and then I am going to use logs to solve because when you have a variable in your exponent, you know you need to use logs. Okay, so let's start with filling out what we know. So I know that since it's compounded quarterly, I'm going to use this formula. And so with the y equals a times b to the x, I know that my y is, well, if it doesn't give me a starting value or an ending value, I'm just saying 100 for the starting. And then since I want it to double, my y will be 200. And then my b value is 3.6% compounded quarterly. So my b is, I have to figure it out using the 100% plus the 3.6% over 4 quarters. And I'll just calculate that over here is 0.9% quarterly. So that gives me 100.9%. So that means that the B value that I will use is 1.009 because I moved my decimal. And then finally, X, I don't know X, but I know that X is going to be a number of quarters in the end. And so then I'll have to do something to turn it into number of years because when it says how long, it wants to know how many years will it take. All right, so Y is 200, and that equals 100 times 1.009 raised to the X. So I'll start by dividing by 100 on both sides because remember, I want to get the power alone. So I divide both sides by 100 because that's the opposite of multiplying. Then I get 2 equals 1.009 to the x, and now I will take a log. If I had done the equation with the e in it, the continuously, I would take the natural log because that's log base e. But here, my base is the 1.009. And so I will say log base 1.009. Sorry, my mouse is being funny. Okay, log base 1.009, and then remember we separate the base and the exponent, and then the argument is here. So I'm going to put that into my calculator here. So I'm going to type log and then shift minus sign to get the base, and then I will just right arrow back out to get that 2. don't know why it's not working. I guess maybe scientific calculator doesn't do this kind of log. So I'll have to do this. Well, that's a reason to use the graphing calculator. This is the change of base that we talked about before. So if I go to graphing calculator and I do log base 1.009 of 2, it works. Wow, that's interesting. I did not know the scientific calculator didn't do that. So then I get 77.362. Remember, that is a number of quarters for my x. And so then to figure out how many years that is, there are 4 quarters in a year. And so then I will divide that by 4 to get my number of years. Again, I don't like to round until the end, so I will just copy, Control-C, Control-V, and divide by 4. And I get 19.34 years. Okay. So number 2 is asking, what if it was continuously instead? And so that's where we will bring up this part where we use the a times e to the RT, and we talk about how it's a little bit different. So if it's continuously, and I have y equals a times e to the RT, remember my y was 200, my a was 100. I start with $100, I'm doubling it. My R is a percent. It's not 100 plus anything. It's just the percentage, which is 3.6%, which I will change to a decimal. And the T is the thing that I don't know, but it is in years. So I won't need to do anything differently at the end. I will get a little bit different time. So 200 equals 100 times e to the 0.036 times t. I will divide by 100. So now I will use the natural log, because the natural log, remember, is a log base e. ln is the same as log base e. So I want log base e, which is ln. The exponent goes over on the right side, and then the argument is the 2. So in order to get the t completely alone, I will divide both sides by 0.036. And so then I have that my t is, let's see, ln of 2 divided by 0.036, and I get 19.25. So it takes just a little bit less time if you are compounding continuously at the same rate.